two additional types of macro system variables were introduced. The duplicate labels are going to be generated in the expanded source code. These qualifiers are prefixed by the dollar symbol. I have to set some variable. I have to set some value to it. Hello everyone, it is Dr. Ravi Kumar YB, the Department of Computer Science, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. In today's session, we shall see as to how we can solve the problems of PUTC function definition which you have come across in the previous sessions. With respect to the macros, which I have already discussed with you guys, we have different types of problems in the earlier versions of macro expansion. Today we shall see one of the problems which the programmers had been facing with the macro expansion, and as a result of that, what was the problems and challenges being faced by the programmer at the time of pre-processing, also called as macro processing. The pre-processing involves the first version of PUTC, which I discussed in the earlier class, had a problem. Let me discuss the problem and how the problem can be resolved with the second version of PUTC, and what was the limitation of second version of PUTC for the programmers, and how they overcome the problems of the second version of PUTC in the final version of PUTC program. That is, a PUTC is a macro definition, and how the expansion of these macro definitions in the source program going to be helpful in the final version of PUTC is going to be explained in the today's session as well as in the next session. Let me take you with the problems of the first version of PUTC which I discussed in the previous session. Here, the PUTC macro definition given as a first example as a severe flaw in that it can only be used once in any given assembly language program. What is the meaning of this? Suppose if I have any looping statement, then I will be repetitively calling the same set of statements or executing the same set of statements until some condition is satisfied. Once when the loop is executed for the first time, the expansion of those statements is clearly done in the source program. Next time when the same iteration is carried out, the same set of labels are generated. That is, the duplicate labels are going to be generated in the expanded source code. That leads to a confusion for the interpreter which statement to be executed. The same thing is explained here. If it was used a second time, the labels PUTC and PUTC loop would get generated again in the expansion of the PUTC in its second location. That is, it finds a duplicate labels in the expanded version of the source program. With this, which in turn would cause a duplicate label error when the expanded code is passed on to the assembler. These kind of duplicate labels generated at the time of expansion leads to a confusion for the assembler. So this is the major drawback the programmers identified in the macro expansion with respect to the labels generated iteratively. That is, for example, looping statement. So in order to avoid those problems and to correct this problem, two additional types of macro system variables were introduced to go with the ampersand prefixed variable names of the prototype statement. That means, suppose if there are some of the variables which gets generated more than once, that leads to a duplication of labels in the source program, that is in the expanded version of the source program. In order to avoid such problems of duplicate labels in the expanded version of the program, they thought of providing a solution to this problem in the form of set variables. What is the meaning of set? I have a set keyword here. This set keyword is a directive that has the ability to direct the assembler to uniquely identify any two different types, any two similar type of variables or any two similar type of labels generated uniquely. Please be careful that I am using the labels generated for more than once, but more than once means there is also a possibility of having the duplicate labels for n number of times, that is more than 2 times. That is the mistake. Again, a problem they faced in the first version of the PUTC method of macro expansion. That is, in this case, they used this ampersand symbol as a prefix to uniquely identify two similar labels, two similar duplicate labels generated by the macro instruction. What if there are 3 similar labels, 3 duplicate labels, or 4 duplicate labels? They addressed this problem of 3 similar labels or 4 duplicate labels in the second version of PUTC macro expansion. Finally, in the final version of macro expansion, they eliminated the complete problem of duplicate labels used in the expanded version of the source code. That is, let us see to the first version of the source program, that is PUTC macro expansion, in which how the duplicate labels are addressed. Two similar duplicate labels are addressed. In this case, they have used the set label, which is a directive that directs the assembler to go with the symbols of similar type. If that is the case, let me call the second type of thing as system qualifiers. These qualifiers are prefixed by the dollar symbol. First one is the ampersand symbol, set variables. The other solution which they came across is system qualifiers. These system qualifiers are the prefixed symbols with a value that is automatically adjusted to a new value each time a macro expansion occurs. Example, $loop. Dollar is expanded to the form of $AA for the first macro expansion. For the second macro expansion, $AB for the second, and so forth. For the third macro expansion, what happens? What is the solution which they add in the first version of PUTC method? Let me take you into the example program. These macro text elements can be concatenated together. For example, if the prototype statement has the label ampersand in it and appears in the macro definition in the construction. For example, 1 ampersand in it. We have a set variable here, ampersand in it. Then if the value of ampersand in it is dump x, the macro facility will expand the construction as in this example. See here, ampersand init tends to 1. Then we have ampersand param here. X ampersand param, which tends to y. That states that we have x12y. Where? What is this 12 indicates? This 12 is a value associated with param. How? Let me show you that. See here, 1 dump x is a symbol which you have come across. Here, dump x is used, 1 ampersand init. In place of ampersand init, I have this 1 ampersand init. In place of this ampersand init, I have this dump x. If that is the case, I have 1 dump x. So this ampersand is the symbol that is setting the init to dump x, set variable. Next, so init is tending to 1. We have the delimiter which is setting the value to 1. Next time, we have the value that is init is setting to 1. If you look at this, you will clearly understand that ampersand init is setting to 1. This can be interpreted successfully because the ampersand and the trailing blank allows ampersand init to be identified. This ampersand is there, right? This ampersand is there, and the trailing blank space allows which needs to be identified as uniquely. If the order was reversed, that is ampersand init 1, this would not be possible. For this case, the symbol tends to, or this symbol is used to provide a right delimiter. What is the meaning of this? Let me clarify you that. We have the ampersand init here. We have the value here, 1 ampersand init. 1 ampersand init. We have a delimiter blank space here. We have a blank space here. What if the same thing is reversed? That is ampersand init 1. In order to avoid this blank space, this does not work. This works because 1 is the macro name that is associating with the set variable. These set variables are preceded by the blank space, which leads to a delimiter, which is considered as a delimiter. A blank space is considered as a delimiter here. In order to avoid the delimiter, if I reverse the thing, that is the prototype from ampersand init 1, that is from 1 space ampersand init to ampersand init 1, that leads to a problem because that is not identified accurately here. So this is not going to be worked out. So in order to do this, this is the blank space, that is a delimiter identifying this as the name of a macro and this as the parameter. So if that is the case, if I use that 1 as a macro name and dump x, then init x tends to 1. That means init is a variable that is defined for the macro 1. That is defined for the macro 1. Now I have the construction such as x ampersand param y. I have another qualifier, the second one, system qualifiers. These system qualifiers always begins with dollar symbol. See here, we have the ampersand symbol here. What does that indicate? The ampersand symbol indicates that it is a set variable. That means it is going to set some value. For which one? X. We have X ampersand param tending to Y, which generates that X tends to Y. Then what is the param indicates here? Ampersand param. Ampersand param as the value 12. So we have the location that is X. Let me write down in terms of the capitals. X ampersand param tending to 1. See here, we have init tending to 1, then X ampersand param tending to Y. But in this case, it is associated with which macro? With the macro 1. So let me rewrite down this as X ampersand param tending to Y. If that is the case, there must be some value associated with this ampersand param. So let me write down this as X12Y. So this indicates that the value 12 is associated with this ampersand param, which is a set variable. The set variable is assigning this. This is a set variable assigning some values associated with this param to this. If that is the case, let me take you into the more detailed information. If we revisit the PUTC macro taking advantage of set variables, an improved construction might be like this. We have the set variables with the symbol ampersand GCNT. That means count. We have the global set variable. What is the meaning of global set variable and local set variable? If I use the set variable with this GCNT, ampersand GCNT, that what is the value associated with it? 0. See here, then in this place what happens? This becomes 0. So this becomes 0 here. 0 plus 1, that becomes 1. What is the value being set here? Ampersand GCNT is incremented by 1. So it becomes 1 now. Save ampersand GCNT. What is the value going to be saved? 1. That is 0 plus 1 is set here. Then it is going to be saved in the STA, that is store accumulator. We have ampersand INT here, INIT. Now we have the symbol ampersand INIT. We have load character here, LDCH, which is that character. The character passed as a parameter to this function is used here, ampersand character, which is the next parameter from which device I am going to read the character and going to be printed. That is the same thing. We have the TD is the device name, ampersand device, that defines the device from which the character is going to be read. Once it is read, it has to be printed. The same thing is going to be explained here. We have the jump. When it is going to jump, the loop, ampersand GCNT. So we have the loop statement here. What is the meaning of loop here? We have the loop statement here, GCNT. GCNT is the value of GCNT is what? 1. Save ampersand GCNT. What is the value of this GCNT now? 1. It is 1. What is that reserve word? We have 1 here. 1 word of memory location is reserved. Then we have loop GCNT. Where do we have this loop GCNT? It is there again here in this expanded version. Again, what happens? Jump if equal. Jump if equal. What is the meaning of loop once again? Repetitively executed. What is the value of this GCNT next time? Jump. we have jump here, we have jump if equal here. That is, if the condition is satisfied, repetitively executed statements are going to be placed in the expanded version of the macro definition. Then we have WD ampersand device again, TD, WD. Then LDA, we have save ampersand GCNT. This indicates that we have GCNT 2 times here. We are going to save GCNT, save GCNT, loop GCNT, loop GCNT. Loop GCNT is in which location? It is in this location. So next time it is incremented, what happens? It has to be incremented by 1. If it is incremented by 1, what happens? It becomes 2. But in this case, it generates a duplicate values. That is, we are not going to have the similar set of statements. That means when it is first executed, it is going to get the value that is 1 in this location, set variable. It is going to save that. What is that character it is going to receive? That is whether it may be S or P or M or anything, N or anything. This is the character going to be read by this device ampersand DEV. Then once it is read, it has to be assigned with some values. If it is considered as 1, if it is considered as 2, if it is considered as 3, if it is considered as 4, then each of these characters must be uniquely identified with some variable, with some values. That is this. S is assigned with value 1, P is assigned with value 2, M is assigned with value 3, N is assigned with value 4. If S is assigned with value 1, and P is also assigned with value 1, then again the assembler leads to a dilemma whether to print S or to print P, because both of them have been assigned with a set variable 1. So immediately what is the problem they identified is this, in the first version of this. So the global set variable takes place as the macro definitions are read. The initializing the set variable to 0, it is subsequently incremented by the internal set statement. Each time the PUTC macro is expanded. But see here, we have the statement here. PUTC definition is invoked. What is that line indicates? Wherever we have that, that is going to be exchanged. That is X and 04. X is the character. X is the character from which device? Device identified by the value 04. Then STA. Jump if equal. Jump if equal, next. It comes to the next. Here. It comes to here. STA last. Store accumulator with last. But if it is not equal, what happens? Once again, PUTC function has to be, information has to be placed here. PUTC. If that is the case, we have dump X, PUTC, line, comma X, comma X, comma 04 from the same device. If I call the same function, if it is not equal, if it is equal, it goes to next. That is, skips the execution of this statement. Otherwise, what happens? It has to invoke once again the same set of statement. If that is the case, what happens? Again, the PUTC must be placed here. PUTC function call, that is line, comma X is equal to Y, comma 04. Y is the character going to be read from the same device 04. Again, if it is not equal, once again the same macro definition is to be invoked. PUTC line, comma X, comma equal to Z, comma 04. From the same device identified by the value 04, I am going to read one more character, that is Z. So we have these three characters, X, Y and Z are the characters identified. But what is the value I am going to have here? What is the value I am going to have? The character X, Y and Z are read from the device identified by the value 04. If that is the case, and if I have multiple duplicate copies of this must be identified with some value. Which is that value? I have to set some variable. I have to set some value to it. Which is that value? This must be 3, this must be 2, this must be 1. So that the characters received from the device identified by 04 is going to be printed. If it is not uniquely identified, then there is a problem in printing the values, printing the characters. So if that is the case, for the sake of illustration, assume that 4 prior macro calls for PUTC have occurred before the macro facility encounters this code fragment. So the value of the global set variable ampersand GCNT has incremented to 4. Then the expansion in this case will be, let us see to the example program. We have the value here. How many times the PUTC is called here? We have the jump if equal. PUTC is used once here. Now, what is that character? X, which is the device 04. In place of X, we have this is the character going to be read. Once it is read, it has to be stored in the accumulator. Store 5 we have. Then load character, which is that character? X is to be loaded from the line into the this. Then we have J jump loop 5. 5 times it has to be repetitively executed. Then if that is the case, loop 5. Where do we have loop 5 here? We have loop 5 here. We have the loop 5 here. This indicates that this is the statement which needs to be executed, x equal to 04. We have jump if equal loop 5. Where do we have the loop 5 once again here? It jumps to this location TD x04. Jump if equal loop 5. Jump if equal loop 5. Jump if equal loop 5. But every time when it is called, it is going to have the value x, y04, z04, a04, b04, so on till like that. If that is the case, how many characters are going to be read? See, look at it. We have store accumulator next at the last. Please notice that the expanding the call, the macro facility incremented the value of GCNT from 4 to 5. That is from 4 to 5. Now, this problem, there is still a potential problem with the approach of using the set variable, because the global set variable will initialize the set variable to 0 to every places which I am using the variables identified with ampersand symbol. But there is a problem with this. See, because the name such as save 3, loop 5, save 5, all those are variables I am using, is one of the programmer might use, and so inadvertently set up code for which the macro facility produces a duplicated symbol. Again, it generates a duplicated symbol like save 3, save 3, save 5, save 5, loop 5, loop 5. If you observe this, you will see that loop 5, loop 5, save 5, save 5, save 5. Save 5 is a label used here once, but how many times it is used? It is used 2 times. Again, that leads to a problem. If I have the 2 duplicated symbol, it works. If I have more than 2 duplicated symbol, what happens then? See here, 4 to 5 it is incremented. The value of this is incremented from 4 to 5. What is the next thing? If I have once again save 5, what happens? Again, that leads to a problem here. So that is the first version of PUTC program which they came across was identified with this problem. Again, to overcome this, they came across the second version of this macro expansion. What is that indicates that? that indicates that you are going to learn about the second version of PUTC program, in which how the problem was resolved. Instead of having the similar set of duplicated variables, they are going to identify each one of them with a unique values. The same thing is going to be expressed and explained in the next session. Thank you very much. Thank you one and all. If you come across any questions with respect to the topic I discussed today, kindly come back to me during the live session so that I will clarify all of your questions. Thank you very much. Thank you one and all.